So we are back here at 2021 STEM Summit, this time with my dear old friends. I know you're all going to be blown away with Astrobotic. They are delivering payloads to the moon on things like the Griffin during mission 3. That's right, I said the moon, and they are right here in Pittsburgh. So I'm Audrey Russo, President and CEO of the Pittsburgh Technology Council and our subsidiary 40 by 80. And that's where we focus on all things related to education, entrepreneurship, and soon apprenticeships. So today we have students and educators joining us from over 122 different educational institutions. We're just psyched. Many people are listening to this in their classroom. And so we're pretty excited by this opportunity. So I want to say thank you to each and every educator, every administrator, every person that works on the school staff for continuing to face these head-on issues and rise above the formidable challenges that we've all faced, particularly during this 2021 school year. We not only applaud your commitment, but you've just been able to make so many people's lives so much better. And we know that we just cannot afford to leave one child behind, and support for families is incredible. So a little bit at the Tech Council, we work to connect with the talented and curious students of our region to our members, which is about 1,000 local technology businesses, manufacturing firms, and life science related companies. And we work with these industries to help them come together to make sure that this is an incredible place for people to build, such as a company like Astrobotics, live, work, and build their concepts so that we have the kind of regional vitality that we know can proliferate right here. And we're working on changing the world, and Astrobotics has taken us to the moon. So these companies recognize the talents that so many of these students, each and every one of you hold, and want to create the continued excitement that we have as business leaders about your future. So in other words, we really want to hear about all of you, and we want to share with you the fun and exciting jobs that actually are available here to pursue in Pittsburgh. So I mentioned before that you're going to talk with Astrobotics. It's led by the kindest, greatest guy around that's working in our ecosystem. That's the CEO, John Thornton. I've watched him and supported him from afar for a long time. And to see the work that they're doing is just blows my mind. And then to see that they recently announced this Moonshot Museum. Sam Moore, the director, is also going to be on. So our student co-hosts are going to be introducing them in a minute. So now I'm just going to pass the baton over to Marie Poloni. She's Director of Talent Attraction, STEM, and Workforce Innovation. And her role is to connect people and businesses with students and the opportunities in the world of STEM. And she's also our on-site nerd because she was a science teacher, and we pulled her out, and she's helping us change the world. So I want to pass the baton. I'm still going to be on, but I'm muting myself, and I can't wait to listen. So thank you, Marie.
Thank you, Audrey, and thank you to PMI. Thank you for kicking us off with that amazing video, and thanks to all of you for joining us today. Today and every single day of the STEM Summit, we want to make sure that we have lots of interaction from you in the audience. So if you look down at the Q&A in the bottom of your screen, that's where you're going to type in all of your questions. We have student co-hosts here with us today. We have Eris, who's joining us from Compass Charter. We have Zane, who's joining us from SciTech, in part of Pittsburgh Public, and then also Nate from Alderdice here in the city of Pittsburgh. They're really going to be running the show. So they're going to help do polling and get to all of your questions. So now I'm going to hand it over to Eris to introduce our speakers of the day.
Hello, I am Eris, a 10th grader at Compass Charter Schools. I'm so excited to announce John Thornton, who as CEO has grown Astrobotics' business of delivering affordable space robotics technology and planetary missions by attracting technology contracts, equity investment, and payload customers. Under his leadership, the company has booked 3 lunar missions with its Peregrine, Griffin, and MoonRanger spacecraft. At Carnegie Mellon University, Thornton led the build of Scarab, a NASA concept rover for lunar drilling, and the first rover to carry a prototype of the NASA Resolve payload that will now be flying to the lunar South Pole on the NASA Viper rover aboard Astrobotics' Griffin lander. Thornton also founded the Carnegie Mellon University Advanced Composites Lab, a research, training, design, and manufacturing program specializing in high-performance, lightweight composites for robotics. After that, we have Sam Moore, who is the executive director of the Moonshot Museum, a new museum coming to Pittsburgh Northside in 2022, focused on making space more accessible and inspiring people to find their place in the future of human space exploration and settlement through access to real spacecraft and space industry professionals. In this role, he oversees operations, exhibition design, fundraising, programming, and outreach for the museum. Please enjoy.
Fantastic. Thank you so much, Eris, for the very kind introduction. So my name is John Thornton, the CEO of Astrobotic. I'm really excited to be here with all of you today. So first, we really want to encourage a really interactive session. So we're going to kick things off with some questions for you. So the first question is, what classes do you think you need to take to work in the space industry? And multiple choice question here. So is it science? Is it math? Is it writing, art, history, and civics? So we'll give a minute for the answers to pull in. I'm already seeing them streaming in here. Just going to pause here. So maybe while we're answering that question, just looking around, we're here in Astrobotics clean room. This is where we build up our spacecraft for actual flight to the surface of the moon. And right behind me here, this is actually one of our first spacecraft that will fly to the surface and deliver cargo to the surface of the moon for the very first time a little bit later this year. Looks like the polling questions have pretty much stabilized here. Looks like the number one answer so far is math, followed by science, writing, art, and history and civics. So it turns out that you can take any of these classes and find your way into the space industry. So a lot of people think you have to be really good at math or really good at science, and that helps on the engineering side. But you can also be a business leader like myself, and arts and humanities is really good. You can be a space lawyer like my wife happens to be, and you can do history and civics. So you can really approach space in a lot of different ways, and even the arts. We need people that can generate the graphics, the designs, the videos, and create the future creative approaches to how to settle the surface of the moon and other places deep in space. So thank you for this question. We've got one more for you, and then we'll kick things off. So the second question, what can we find on the moon that could fuel rockets? So there's lots of things on the surface of the moon. So is it nitrogen, water, carbon, oil? What can we find on the moon that could fuel rockets? And the big idea here is if we can find fuel on the moon and use that to fuel rockets, we could then turn the moon into a gas station, a refueling station, so that we could go deeper into space. So you can fly your spacecraft to the moon, refuel, go back and forth as a service in lunar orbit down to the surface, or maybe even refuel to go to Mars or deeper destinations. Looks like we've got our responses here for this poll. So thank you for answering these questions. So it looks like the number one answer is nitrogen. The number two answer is water, or number two answer is carbon. Number three answer is water. And the last one is oil. So everyone's correct. As far as we know, there's no oil on the surface of the moon because there was no life there at any point in its history, as far as we are aware. But it turns out the answer to this question is water. And that might sound weird, but you can actually take water because it's made up of hydrogen and oxygen. You can split it using electrolysis, which is an experiment that a lot of people will do in high school in the science classes. And then if you take that hydrogen and oxygen and condense it, that's actually rocket fuel. That's the same fuel that powered the space shuttle. So if we can find water at the moon, and in particular at the poles of the moon, it can become a fuel source for future spacecraft to fly in and around space and around the moon. So thank you for answering these questions. I do hope that you come up with your own questions to ask us at the end of this session. So with that, I'm going to get into a little bit of an intro of Astrobotic and what we do here at the company, and then I'll turn things over to Sam that can talk more about the museum experience that we're opening here. Just pull this up. All right, so this is Astrobotic. We are in the business of making space accessible to the world. But first you have to ask the question, why space? Why should we go back? What's so important about space? It turns out it's a $425 billion industry. And some of the biggest segments of space right now are in communications. Think satellite phones, satellite TV, satellite radio. And you can actually get internet at home now with satellites. And then navigation, we have all of this in our pockets these days with our phones. A GPS signal comes from a series of satellites that are orbiting Earth today. Earth observation is an increasingly important topic as we learn to protect our own world and make sure that it can be a place to thrive for generations and generations to come. So a lot of data from Arctic sea ice movements to weather comes from Earth-looking satellites. And then there's a lot in defense. This is primarily in communications and real-time data coming back from orbit. But again, this is all part of a massive $425 billion industry worldwide for space services. So Astrobotic is focused on the moon. So why the moon? What's the big deal? So first, we already touched on the idea that it could be a place for fuel. We can create water at the poles of the moon, and we can find it frozen in those areas and turn that into rocket fuel. There's other resources on the moon too, like rare earth metals and other building blocks that we can use to create spacecraft and create spacecraft replacement parts. We can eventually learn to live off the land on the moon, probably using greenhouses in different ways that we can have water and nutrients fueling those plants. And then exploration and research is a huge, huge topic on the surface of the moon. So we actually, that picture in the top right, it looks just like a crater, but it's actually an entrance to a cave underneath the surface of the moon. And if we could get under the moon and we can learn to live off the land with these other using these other resources, we could potentially settle the moon. And that's the really big step. If we can go to the moon, live off the land, not use Earth resources, we can truly become a multi-planet species and really push our whole species forward into the stars. So what we do here at Astrobotic is very much like a shipping company. Think DHL, UPS, or FedEx or Amazon. We take those packages from our customers, we put them on our lander like the one right behind me here. We then take our lander, we ship it down to Florida, put it on a big, tall, 200-foot tall launch vehicle and fly it up to the surface of the moon, where we then land those payloads, our customers, and deploy them down on the surface. So we do landers, like in the top left here. We actually have an instrument right now at the International Space Station. That's a picture of it floating there. It's a series of audio sensors listening to the sounds of the space station and looking for anything that might go wrong. We also get to do some really fun field tests here on Earth. And the picture on the top right, the video is a shot of one of our systems flying over the desert in the Mojave Desert out in southwest Pennsylvania, southwest America, and we're looking to test our landing sensors. This is a combination of stereo cameras and lasers building up a site map to get a good soft landing demonstration so that we can then use that same tech on the surface of the moon. We also do rovers at Astrobotic, and a little bit of a pause. Oh, there we go. Whoa, jumping back. So our rovers at Astrobotic are big and small. They come in lots of different sizes. I'm not sure why that slide's not working for me. Oh, there it goes. So we've got small rovers, cube rover scale, that would be the size of a toaster oven. We also have larger rovers like the one in the bottom left that can potentially go to the poles of the moon and drill for water. So all these rovers are the ways that you can drive across the surface, take your instruments across, get measurements from lots of different locations on the surface of the moon. So what's the big deal? Why is it so hard to go to space? Why do you need all this engineering expertise? The first thing is surviving launch. So to survive launch, to go up into space, you're strapped down to the seat of the launch vehicle, and you're shaken around in a big, harsh environment. You're shaken vertically and laterally. You're pushed down in the seat with about 8 times the force of gravity, and you have to survive that. So we use a shake table, which there's a picture on the left here that can move up and down very, very quickly and simulate that environment. It's a very rough ride, so we need really good mechanical and structure engineers that can support the vehicle and make sure that it can survive that launch. The next is communications. The moon is really far away, so you can't make a cell phone call to the moon. There's no GPS on the moon. So we need big power antenna that can send data back home to be able to communicate. And it's so far away that it actually takes 6 seconds and as many as 9 seconds round trip for a data to go back and forth. So that means if you press forward on your joystick for your rover to drive it forward on the surface of the moon, you won't see it move for up to 9 to 10 seconds for that to go all the way around. Some of that is physics and some of that is ground effects here to just get the internet connection between us and the big satellite dishes that communicate to the rovers. Another one is the space environment. It's super cold and it can also be super hot in space, and it's all in a vacuum environment. So we actually have a test piece of equipment here pictured on the right. It's called a thermal vacuum chamber. So if you're inside of this chamber, you're very close to the space environment. It pulls down to that absolute vacuum and it can go hot and cold. So we'll test all of our equipment inside of here to make sure that it can survive the extreme hot, extreme cold, and vacuum environment of space. So our first mission, Peregrine, flies towards the end of this year and delivers a series of payloads to the surface of the moon. Our second mission is an autonomous rover that's going to be delivered by a different company at the pole of the moon and drive around. This is in partnership with Carnegie Mellon University and some students and professors there that are building this. And then our third mission is the Griffin mission. This is actually the first one to go look for the water at the poles of the moon. So it's going to have a drill and we're going to drive into the permanently shadowed craters at the poles of the moon, which are super, super cold, near absolute zero cold, so that we can drill for water and potentially one day turn that water into rocket fuel. So just a little bit more on our first mission. This is our mission patch that we just unveiled for the first one. This is going to be our country's first landing on the surface of the moon in almost 50 years. That's not since Apollo have we been back. And it's the dawn of a whole new era of commercial deliveries to the surface. NASA has 6 lunar missions already on contract in the coming years and more being booked each year for returns. We're going to see a whole resurgence of excitement going back to the surface. We've also been testing our spacecraft. So the one that's sitting right behind me here has been tested in lots of different ways. The picture on the right is one of those big giant shake tables. So what that thing is going to do is going to shake it laterally and vertically with really strong frequencies to make sure that it can survive. And so far it's so good on the test results. The picture on the left is really fun. Those are giant speakers and a big array of giant speakers blasting the spacecraft with sound. And you might say, well, what could sound do to the spacecraft? Really high frequency sound can potentially couple with the big flat surfaces. Think about like a drum that you play in band. You hit the drum and it vibrates. That same sound that's coming from the frequency of the speakers can couple, can vibrate at the same frequency and could potentially cause a damaging impact on our spacecraft. So we test the spacecraft with sound as well as physical vibrations. So our first mission is going to bring 6 nations to the surface of the moon. And lots of different folks that are sending all kinds of different things. So NASA is going to be one of our payloads that are going on our first mission. They're sending 11 payloads, in fact. Some of these are looking at the composition of the ground, the soil at the surface of the moon. Some are looking at the radiation environment. Some are looking at what happens to the dust when you land on the moon and it flies away from the spacecraft. Is that going to be a problem for future landers? We also have a series of commercial. Having a little trouble with the slides here. Just going to jump ahead. We have I don't know what's going on. Okay, there we go. Sorry about that. We have a series of commercial payloads flying with us as well. The first MoonArt is going to be flying with us on the first mission, the picture in the top left. We've got a walking rover that's going to be walking across the moon in the picture in the top middle there. We've got 2 crawling rovers, one being made right here in Pittsburgh at Carnegie Mellon. And then Mexico, there's a university in Mexico building a series of small rovers in the picture in the bottom center there. And then we also have a program called Moonbox, where people from all over the world, and this is designed for individuals, can send things to the surface of the moon. So there's an future astronaut, Astro Liz in the UK, that actually is sending her sticker to the surface of the moon. And we have lots of other students and time capsules and all kinds of things that are going to be sent up with us on this first mission. including students from here in this city. So with that, I'm going to turn things over to the Moonshot Museum because for us as a company, we're all about making the moon and space accessible to the world. And the Moonshot Museum is how you can come experience the thrill of spaceflight along with us. So Sam, do you want to take it away?
Absolutely. Thank you, John. So like John said, we are right on the edge of a whole new era of exploration of the surface of the moon and exploration of space. I got confused with my mouse here. So next summer, we're opening an entirely new museum. It's going to be located in Astrobotics headquarters on the north side of Pittsburgh. And this is really special for a couple of reasons. It offers behind the scenes access to actual spacecraft and actual space professionals in a setting like Astrobotic that's returning to the moon, which is really, really exciting. And one of the keynotes of this experience is actually going to be the chance to look into the room that we're sitting in right now. The clean room isn't activated right now, so John and I are in here without scrubs and completely suited up. But when you come to the Moonshot Museum, a major feature of our space is that you're going to be able to look through the windows and see spacecraft as they're being built, see them in various stages of development, and know that what you're looking at is going to be on the surface of the moon in the not too distant future. And what's really exciting for us is that there are so many opportunities available to work in space. And that's something we're really going to focus on at the Moonshot Museum. We want to inspire you to find your place in the future of human space exploration and settlement. And there are so many opportunities to do that. This is a snapshot of just part of Astrobotics' team, with jobs ranging from engineering to science to marketing, and we'll get into a little bit more of that. We're at the STEM Summit today, so obviously there are tons of opportunities to work in space, in science and technology, engineering and math, aerospace engineers, systems engineers, astronomers and biochemists, doctors of all kinds. Something you might not think about is that space has very interesting effects on the human body, and so medicine is constantly gaining greater understanding of how space impacts humans. And as we spend longer and longer times in space and on the moon, it's going to be important to understand biologically how that impacts us. There are also jobs that might not initially occur to you in math when it comes to space, because a company like Astrobotic and companies that work in space need accountants. They also need data analysts to keep their numbers straight. So even if you're not actually building the spacecraft that are going to take you to the moon, there are a lot of opportunities to use those science and technology skill sets in the space sector. The thing is, though, and for those of you who are sitting in science class today, you know, math isn't your strongest subject or science isn't your strongest subject, what I want to let you know, and what we're really going to focus on alongside these engineering and technology opportunities, is that returning to the moon requires people of all different backgrounds, of all different skill sets. And that includes the arts, humanities, and business. John started out as an engineer. John is now a business leader and running a complex corporation. It's also really, really important in order to sell what your company is doing, in order to promote what your company is doing, to have artists and writers and marketers, communicators, people who are really strong, have strong social media skill sets, and salespeople working in space. John mentioned earlier, he's married to a space lawyer. As more and more countries are going into space, as more and more spacecraft are sent up to the moon, it's going to be really important that the laws are clear and agreements are clear and contracts are negotiated clearly, and there's a special role for law. Artists and writers and photographers, like I mentioned, when you see beautiful pictures of rockets and landers and videos of how things are going to work and renderings of what spacecraft will look like after they're completed, we need people to do that work, to put a creative vision alongside an engineering vision to bring it to life. Here's the thing. All of this work, everything I just described, from engineering to law to art and writing, all of that work is actually happening in Pittsburgh right now. So certainly, there's a lot of work happening in Florida and in Houston and in DC and Los Angeles and San Francisco that all focuses on the space industry, but you don't actually have to go to one of those space coasts to get involved in that work. And so pursuing STEM, pursuing your passions in arts and humanities is possible here in Pittsburgh, and it's possible to get involved in this work here locally. So I'll run through just a couple of pictures of early renderings that we have for the museum space. We're really excited, like I said, to be able to expose Pittsburgh and share all of the potential that exists for exploring space with Pittsburgh, and really share the message that space is for everyone. Like I mentioned, you're going to be able to come back time after time to the Moonshot Museum and watch a spacecraft go from early stages to full development before it leaves the building to go launch up to the moon. We're also going to have the opportunity for you to kind of follow your passion as you make your way through the space. Choose activities that line up with what your interests are and tackle missions at the Moonshot Museum. And what we're really excited about, John was talking about the Moonbox project, your ability to actually send something to the moon. You're going to be able to do that at the Moonshot Museum. So part of every museum experience is going to be sharing a hope or a memory or a handwritten message that's going to then be digitally transferred and sent up to the moon and be there for years to come. For the teachers who are out there, we're over the next several months going to be building a lot of resources for you to use from partners here locally in Pittsburgh and throughout Western Pennsylvania, from our partners at NASA, to bring together curriculum and education materials that you can use in your classroom before you then link those with visits to the Moonshot Museum after we open next summer. The best way to stay in the loop is to visit our website at moonshotmuseum.org, subscribe for updates there, and stay tuned because there's going to be a lot of really exciting news coming out about the museum over the course of the next year.
So with that, thank you all. Really appreciate your times today, and would love to have any questions if there are any questions.
That was absolutely fantastic. I'm going to not nerd out quite yet on all of that great information. I'll wait until the end. But down there at Q&A, if you just want to put your questions in, that would be fantastic. And I'm going to turn it over to Nate to get started. Nate, you can start with those first two questions there.
Sure. So somebody asked if you have done any research into electromagnetic railgun launch systems as an alternative to rockets, and if you think this is like a viable technology for the future.
Cool question. So electromagnetic railguns. So for those that are less familiar, that uses a series of electromagnets to accelerate something really, really fast. And what you need to do to escape Earth's orbit and to get into Earth orbit and even go to the moon is you need to go really, really fast. So the way we do that right now is with rockets. And it takes minutes of rockets firing and firing and firing to get up to that speed. The theory with an electromagnetic railgun is you could do very large scale, similar kinds of launches. The big challenges that I'm aware of with that one, and it is very, very early in development for people, would be the vast amount of G-force that would be imparted on the human body. The acceleration of a railgun is extremely, extremely fast. If you've ever watched a YouTube video of it, they use it in the military. It's kind of like shooting a gun. So I wouldn't want to ride one. It would probably hurt people, but it is potentially possible maybe someday in the future if we can figure out a way to slow the acceleration down or manage that acceleration in some other way. So one of the best ways to get to space right now that is the new big innovation is a reusable launch vehicle. So SpaceX is making big leaps and bounds in that way because the traditional approach to space is you take a launch vehicle, you fly it up, and then when you're done with it, you throw it in the ocean. So it's one-time use. Imagine if we did that with airplanes. So for going to space, if you can reuse your launch vehicle, you can approach the cost of fuel to get up there. So you could dramatically reduce the cost. And we're already seeing that with reusable launch vehicles.
Great, thank you. We have, there's two more questions in the chat, and then we can move over to the other Q&A chat. But somebody else asked, as a result of Astrobotic and the Moonshot Museum, what other types of businesses do you see starting here in like the Pittsburgh region to help support the space technology ecosystem? And they also said, thank you for the awesome presentation.
Great question. Thank you. So Astrobotic is in the business of robotics, and robotics in space, and Moonshot is the window into that. But there's a lot of other opportunities for space in the community. So University of Pittsburgh, for example, has an advanced computing group that does space computing. And computing in space is not as simple as taking like your computer at home or your iPad and putting it up into space, because there's this thing coming from the sun called radiation that actually makes it really hard for standard computers to survive and operate in space. You can have the equivalent of a blue screen of death happen on your computer in space if you're just using standard equipment. You can also have thermal problems. Most computing chips here on space or here on Earth are cooled with air. So think of the fan in your computers. In space, you don't have air, so it's much harder to stay cool. So University of Pittsburgh has great computing. Carnegie Mellon is doing lots of space robotics. There's a few other smaller companies in town also doing robotics related work. We also partner with companies like Westinghouse, who are looking at nuclear energy for space. There's also lots of suppliers, everything from building up the circuit boards to actually power and operate the spacecraft, to machining the parts to actually fly. So and we try to keep all of those suppliers as local as we can here to Pittsburgh to grow up that capability. So I think we'll see a lot coming out of the universities of new businesses, and we'll see a lot of additional suppliers popping up here in town.
That's very cool. Somebody else asked, how quickly can autonomous vehicles that are used in space return data back to Earth?
So autonomous vehicles are just as limited as human-powered vehicles for sending data back to the Earth. But the reason that autonomous vehicles are so important for space is because of that lag time. So as I talked about, physics says about 3 seconds lag time between here and the moon. And then ground network effects can make it up to 10, maybe if you're having a little lag, you can actually get up to 30-second delay. So if you've ever tried to play a computer game online and you get really bad lag, imagine trying to do that on the moon with a really expensive robot. It's really hard to do. So that's where you need some level of autonomy. Your robot has to be able to control itself, to sense the environment, and be able to make sure it doesn't get itself into trouble. So a rover, for example, would need to be able to sense a rock and make sure that it doesn't drive over it and tip over by accident. Or our lander, for example, needs to be able to land itself on the surface of the moon, because we will not be able to command it in real time as it's coming down. So once we command at the beginning of landing, we're going to hands off and hope it works, and hope we've done all of our simulations and software correctly. It's a really, really challenging, unforgiving environment, but one that we're very excited to be a part of.
Somebody else asked, when do you think the next human will go to the moon?
Awesome question. So NASA is in major work on exactly that. So they have a big program called the Artemis program, where they are going to be landing the first woman on the surface of the moon inside of this decade. And from everything that I can see, they're progressing really, really well on that path. Astrobotic is actually having some of the first precursor missions, the robotic missions, leading up to those human landings on the surface. So I think we're going to see several human missions this decade back to the surface of the moon. And hopefully that's the beginning of building a small outpost and learning to live off the land and learning to use the resources of another planetary body to really thrive. I mean, if you think about how we operate and how we explore space today, all of the resources that we use in space come from Earth. Everything from the food that the astronauts eat to the oxygen that they breathe, to all of the replacement parts that they have, that all comes from Earth. But imagine one day if we could use the resources of another planetary body like the moon or Mars or any other place, and say 3D print replacement parts from the local terrain, grow food on the surface of the moon, extract water, extract oxygen. If we can do that, then we can really become true space explorers, like no kidding, like Star Trek, Star Wars, in our solar system, to go to other destinations and learn and really survive off the land.
And then a follow-up question to that is, somebody was wondering, how long would that trip take from the Earth to the moon?
So for an astronaut, you want to get there very, very quickly. to go back and forth because you don't want to spend too much time out on the surface. So when Apollo went, when the first astronauts went to the surface of the moon, their trip out was 3 days and their trip back was 3 days. Our robotic spacecraft can take anywhere between 5 and 30 days. Basically, if you slow down, it's a little bit more efficient. It's kind of like driving a little slower on the highway. You get to your same destination, but it's a little more efficient. Not for the same reasons, but basic idea still applies. So humans will go very quickly. Cargo, like robots, will take its time because it's a little more fuel efficient.
Nate, that was a great job. Thank you so much for doing that. We're going to turn over to Zane to ask a few questions of his own, along with some still in Q&A. And please continue to put questions in Q&A because we do have a few minutes still left.
Some people are interested in knowing what exactly does a space lawyer do?
What does a space lawyer do? There's actually really interesting questions in space. So I get maybe to start at the first step. The most basic is company formation. So Astrobotic needed to be formed. We needed to create a corporate structure. There's a whole bunch of legal documentation. We need to hire employees. There's legal documentation around that. But perhaps the more exciting part comes into play of big questions like who owns the moon? Who enforces the moon? If we land next to somebody else, what happens? What if our rover goes and bumps into somebody else's rover? What happens? So that's where space lawyers come in. So there's actually, there's also international treaties. There's a treaty called the Law of the Moon that prevents the moon and protects the moon from becoming weaponized. So this was back during the Cold War, and we were worried that Russia or previous Soviet Union was gonna arm the moon, or they were worried that we were gonna arm the moon. So everybody had to get together and have a treaty about that. And there's lots of things. Imagine if we go and to start extracting soil and earth from the moon and extract that regolith and start turning it into things. Who owns it? So there's lawyers in the US, and also there's a group in Luxembourg who are similarly thinking about this and creating a construct in a way that commercial companies can mine and own what they mine. But you need a lawyer to figure out and write those policies and write those rules and negotiate and try to get everybody signed on and together. There's actually a Space Policy Institute that focuses on space in Washington, DC. You can go there and study it. We've got a few folks here at Astrobotic that have studied there that focus, it's a whole coursework and a whole degree that you can get in space policy. It's a very, very wide, big topic.
Someone wanted to know what is your company doing different than like SpaceX, NASA, like other space companies?
So I think a lot of what we do differently is that we really focus on the robotics side of the problem. So where we come from Pittsburgh. Pittsburgh is the city of robotics. So we start every system we think as a robot first. Whereas I think a lot of the rest of the industry in space think of it as a spacecraft first. So we will approach problems with robotics. We'll say, what sensors do you need? What's the right software? How do you control these things? And I think because we have all these great universities and all this great talent coming out of Pittsburgh, we have a natural edge because Pittsburgh is the robotics capital of the world. And we combine that and we import space talent from all over the rest of the country. We mix that together and we get world's best space robotics. That's what we consider our special sauce for pushing us forward. And then I think it's just good, innovative business approaches that can push the envelope forward and make a payload delivery service to go to the moon. That it's a unique thing just in itself. We actually sold the very first commercial payload delivery contract a few years ago to a company in Japan, and that led to another one and led to another one, and now NASA is buying very large contracts with us. We got $200 million contract last year for delivery of NASA payloads. Their stuff that they want to send to the moon, and we got an $80 million contract 2 years ago for a different mission that NASA wants to send. So it's combination of innovative business approach and also that space robotics and robotics here in Pittsburgh that I think sets Astrobotic apart.
Someone else wanted to know if you have a job shadowing program.
So we don't have one at Astrobotic yet, but Moonshot Museum, maybe you want to take that on, Sam, because we're thinking about ways that we can engage more and more.
Absolutely. So we're in the early stages of planning out what exactly the museum looks like and what exactly our programming looks like. But like we've been saying, part of what makes Astrobotics so special, John talked about the technology side of that. It's also this community focus that Astrobotic has and the community focus that the Moonshot Museum has of making space more accessible. And so we absolutely want to make people working in space as accessible as possible. And that definitely could take the form of a job shadow program. It could also be that you meet someone here at the museum on your visit who's a volunteer for the museum, but who also during the day or during the week is on the other side of the clean room glass building spacecraft. And so nothing yet, but certainly opportunities like job shadow to come.
Someone asked, what is your ultimate goal? Is it people living on the moon?
Our ultimate goal as a company is to make space accessible to the world. And what that means to us is making it possible for every nation to land and operate payload on the moon. There's only been 3 so far that have ever landed on the moon, and they've all been superpowers. Astrobotic here in Pittsburgh could be the next. So Pittsburgh nation could be the next nation to land on the moon. We want to make it possible for all of you to send things to the moon. We want to make it possible for every other country to send things up there. So that cargo delivery is the first step. And then the next one we want to do is creating infrastructure on the moon. So power and communications. We want to enable even more advanced systems, more longer duration missions, and ultimately lay the groundwork for human settlement of the moon. And that's going to really open the door to our entire solar system, because if we can live and operate and thrive on the moon, we can do that in any other place in the solar system, because the moon is a really harsh environment.
Someone else in the chat asked, does a spacecraft need an astronaut to maneuver it through space when it is being launched?
Great question. So our landers and rovers don't require an astronaut, but there are some times where it could be helpful. So that is an interesting question about they call it a human-robot interaction. So what's that crossover? So we have rovers, for example, and landers, and there could be times that there's very specific, precise maneuvering that's required. So imagine if a rover has a robotic arm on it with a hand, and it needs to go in and manipulate maybe a moon rock or take a sample. You might want to have a human in the loop on that one, as they call it. So a human somewhere in the control pathway. So one way we've been thinking about that is maybe we have astronauts in orbit around the moon that can remotely control robots down on the surface of the moon. Because again, if you remember, that time delay makes it really, really hard. Imagine playing that computer game again with like a 5 to 30 second delay every time you press a command. It's really, really hard to figure out what to do. But if you're in orbit around the moon or potentially down on the surface, you could remotely control robots much, much easier. So you don't have to have a human. Sometimes it could be helpful. But that's also why it's so important to have really, really good software, because the rovers and landers are oftentimes autonomous, and they have to work the first time because space is such a harsh environment.
Okay. Someone wanted to know, when does the museum open, and what kind of things will be in the museum?
Great question. So we're going to open next summer, in summer of 2022. And like I said, we're working through exactly what our exhibitions, and we're actively designing those right now. But the clean room is going to be a really central part of the museum experience here. So seeing what's being built as it's being built and learning more about the missions that spacecraft is going to be on. There's also, we're working on an orientation theater that'll have a really cool reveal experience, take you behind the scenes of Astrobotic and behind the scenes of the space industry, along with the opportunity to get close to things like what we have behind us here, structural test models and spacecraft that Astrobotic builds and tests before they actually send something to the moon. So seeing kind of the ins and outs of those spacecraft, being able to get close, in some cases even touch some of those items, alongside some great programming that'll allow you to connect to your interests, whether that is technology and engineering and robotics, or arts and history and writing, to actual space opportunities inside our exhibitions.
Zane, you did a fantastic job. Thank you to Nate for monitoring all that Q&A. And kudos to both of you for being able to answer all of those very tough questions. I have to say that this was really phenomenal. I mean, out of this world that all of this work is being done, but being done here in Pittsburgh. And you represent it so well. There's a saying that I always hold on to, there's discovery is thinking someone that no one has thought and finding something that no one has found. And that is exactly what Astrobotic is doing, not only here on Earth, but up on the moon. I mean, you have me completely pumped about Astrobotic, and I hope that everybody continues to follow in the work that you're doing and strive to get to that Moonshot Museum. I know that I'm definitely going to be there at your opening. But thank you so much, gentlemen, for joining us today. I need to give a huge shout out to our sponsors because they are why we are able to broadcast this to all of you. So thank you to SDLC partners, BNY Mellon, Philips, CGI, Highmark, Industrial Scientific, and Gecko Robotics, Giftjet, and Sheets. And speaking of Gecko Robotics, that is who will be here tomorrow. Please tune in for that show. They are going to be showing us actual robots that climb the walls in industrial manufacturing sites like a Gecko. Super pumped up for that. And then we have Dr. Zhou on Friday. This will only be streamed live because of the sensitive nature of the material he's going to present about professional athletes, spinal injuries, concussions. So we have 2 more days of the STEM Summit. You don't want to miss it. But this day today was really, really cool. So thank you for joining us. And I hope to get to work with you two gentlemen again. Thank you. Thank you for joining us, everyone.